Unit 6, Section 7. Today we're going to talk about two different formats for defining a sequence. One of those formats is the recursively defined sequence, and the other one is the explicitly defined sequence. So let's start off with the recursive rules. Recursive rules always give the beginning term or terms of a sequence, and then they use a recursive equation that tells you how a sub n is related to one or more of the preceding terms. Now the preceding terms are going to be distinguished by a sub n minus 1. Alright, so this is always going to be the term before a sub n. Okay? So let's get an example of what a recursively defined arithmetic sequence looks like. Over here in example 1, it says to write out the first 6 terms of the sequence, then graph it. A sub 1 is 3, so notice that it gives me the first term. Then a sub n, another way to think about that is the next term, is equal to a sub n minus 1, that's the preceding term, plus 5. Alright, so we're going to write out the first 6 terms of the sequence. So here's term number 1, a sub 1 is 3. A sub 2 would be the preceding term, which would be a sub 1, or 3, plus 5. 3 plus 5 is going to give me 8. To find the third term, a sub 3, then it would be a sub 3 minus 1, which is now a sub 2, which is 8, and 8 plus 5, which is 13. So you can see what we're doing is we're just simply adding 5 to the previous term. Alright, once we have those terms, those first 6 terms, we're going to graph that sequence. So here we have a nice, humongous graph here. Our first term we said was equal to 3. After that, they jumped by 5, so our second term was 8. Our third term was 13. Our fourth term, 18, and then 23. We'll stop here at 23 after those first 5 terms. Keep in mind the graph of your sequence is going to be discrete. These points will all lie in a line because this is an arithmetic sequence. Now, let's scroll back over here to your notes where you have a big blank space here on the right hand side of your notes, because we're going to talk about a recursive rule for an arithmetic sequence and how we write that. In order to write that recursive rule, we start off with a brace that looks like a face, and inside that brace we list the first term. So here's one of the 2 things that you need to know. In fact, I'm going to highlight this in yellow. Here's one of the first 2 things that you need to know. In our example, that a sub 1 was 3. They gave us the first term, 3. Then a sub n, remember this is the formula that generates the next term in your sequence, is going to be found by the preceding term plus the common difference. And I'm going to highlight the common difference here. D is the other piece of information that we needed to know. And that D in our example was 5. Alright, so just keep in mind a sub n minus 1 represents the preceding term. A sub 1 is our first term. A sub n is the nth term, and then a sub n minus 1 is the term before the one you're trying to find. Now that's for an arithmetic sequence, and you saw our example here and what that looks like. Let's talk about the recursive rule for a geometric sequence. So for geometric sequence, remember now they don't have a common difference, they have a common ratio. You still are going to be given the first term or terms in that geometric sequence. We'll do an example coming up here in just a second. Then g sub n, how you generate that next term, is going to be found by taking the common ratio r and multiplying it by that preceding term. Okay, so g sub n minus 1 is the term before the one you're trying to find. Alright, let's take a look here and see if we can apply those 2 rules. It says write the recursive rule, -8, -1, 6, 13, 20. So first and foremost, we need to identify this. This is an arithmetic sequence because it has a common difference of plus 7. The next thing we need to do is identify that first term, which we can see right there in position number 1 is -8. Alright, we are just going to follow the template that we saw up above. which, by the way, if you didn't get that all copied down, go ahead and rewind that video and make sure you get that copied down. You're going to want to have that on your notes. And we're going to just fill in that template, which says a sub 1 is equal to negative 8. A sub n, the next term I want to find, can be found by taking the preceding term, a sub n minus 1, and adding 7 to it. There you have it. There's your first recursive rule for an arithmetic sequence. Next, we're going to do a recursive rule for the geometric sequence. So we see 405, 135, 45, 15, and 5. What's happening here is between each term, we are multiplying by 1/3. So our common ratio is 1/3. Our first term, which again can be found by just taking a look at your position numbers, is 405. Okay, following the rule from up above that we have copied down on our notes, now we're going to say g sub 1 is equal to 405. G sub n, any term in the sequence that I want to find, can be found by taking 1/3, my common ratio, and multiplying it to g sub n minus 1. That's the term before the one you're trying to find. All right, guys, there you have it. You got your arithmetic recursively defined statement, and you have a geometric recursively defined statement. The next format that we're going to learn about is the explicitly defined format for an arithmetic and a geometric sequence. Now, we went ahead and wrote these ones down for you so you don't have to pause the video and copy them down. They're there for reference. Again, the two things remain that you need to know. You need to know what the first term is, and you need to know what the common difference is for an arithmetic sequence. For a geometric one, you need to know what the first term is, and you need to know what the common ratio is. So those two things remain the same. What you will notice now, though, the difference in an explicit rule is that it is defined in terms of n, and n is always the position number. So, for example, notice that n is my variable in both of these equations. This is a superscript n minus 1, and this is just in line with the d. All right, so we want to write an explicit rule when we're given the recursive rule, then find a sub 12, which is the 12th term. All right, so if we look here, I can tell that this is an arithmetic sequence. So we're going to start off by identifying our first term. A sub 1 is 9. Our common difference can be found right here in our formula. It looks like we are adding negative 4. So let's write our arithmetic explicit formula, which says a sub n is equal to the first term, which is 9, plus the common difference. Well, now it's negative 4, so minus 4 times n minus 1. Now we're going to simplify this down. We'll distribute this negative 4 to both the n and to the negative 1. So we have a sub n is equal to 9 minus 4n plus 4 more. Now we're going to add the 4 and the 9 together. That gives me a sub n is equal to 13 minus 4n. And this is a simplified explicit rule for this arithmetic sequence. The final thing it asks us to do, though, is to find a sub 12. And this is the beauty of an explicit formula. All we need to do now is plug 12 in for our n. This gives us 13 minus 4 times 12, which is 13 minus 48. When I subtract 48 from 13, I'll get my 12th term in the sequence, which should be negative 35. Okay, well, let's move on to example 3b. You'll notice in example 3b that this is a geometric sequence, and we can tell that because this is the geometric recursively defined rule. We still have our first term, a sub 1, and this 2 that's being multiplied to the previous term is my common ratio. So we're going to write the explicit formula, which says g sub n is equal to the first term, 1.5, times the common ratio of 2 to the n minus 1 power. Now, when we want to find the 12th term, we are simply going to substitute 12 in for my value of n, and I'll get the 12th term. So that's 1.5 times 2 to the 12 minus 1. We need to subtract 1 from the 12 first. So this is 1.5 times 2 to the 11th power. We're going to let our calculator do that work. So we'll take 2 to the 11th, multiply that by 1.5, gives us 3,072. All right, in our final example here for today, we want to write the recursive rule. Now we're given the explicit formula, and we want to go from explicit to recursive. So I need to know two things. I need to know my first term, and I need to know my common difference, or I need to know my first term and my common ratio. So in our first one here, we have an arithmetic sequence. If you don't believe me, go ahead and find those first few terms. We're going to find the first term by plugging 1 in for n. So 6 times 1 minus 5 gives me 1. There's my first term. Let's find the common difference by go ahead and finding the second term, 6 times 2 minus 5, and you'll see that's 12 minus 5, or 7. The common difference here is my slope in this equation, and therefore d is equal to plus 6. All right, let's go ahead and convert this now into a recursive formula. We're going to make our brace that looks like a face. Our first term we said was 1. And then a sub n, any term after that can be found by taking the previous term, a sub n minus 1, and adding 6 to it. And there's our recursive formula for this explicitly defined sequence. All right, next up we got another one here in example 4b, and we said that this is going to be a geometric sequence. Let's start off by finding our first term by plugging 1 in. That gives us 4 times 3 to the 1 minus 1. Well, 1 minus 1 is 0. Anything to the 0 power is 1, and therefore g sub 1 is just equal to 4. Our common ratio, we can see right here, it's that number that's got the exponent on it, so our common ratio is 3. To write the recursive formula then, we're going to say g sub 1 is equal to 4, and g sub n, any term after that, is going to be found by taking 3 and multiplying it to the preceding term, g sub n minus 1. All right, guys, that's going to wrap up our notes for today. We'll talk more about this stuff tomorrow in class.